Hello. Today we are going to be talking about functions. For most of us, when we think of a function, it is what a thing does. Like the function of a liver is to digest fats, or the function of a bridge is to provide access across water. However, a function in math is a little different, though somewhat the same. When I was still at school, all I knew about functions was that it was a chapter in algebra to be completed and put away. Little did I know that functions are used in almost every field of education. Which is why I want you to think of functions as something that you will always need to know, rather like knowing 2 plus 2 equals 4 or 6 divided by 2 is equal to 3 and so on. Functions is really very important in mathematics. At the end of this lesson, you will be learning quite a few things about functions. You will learn what a function is, what are the many ways it can be written, the types of functions, and then we will talk about its far-reaching applications. So what does a function really do? A function is rather like a machine. You put something into it and the machine does something to it according to a rule we have to define, and we will get an output. Say for example, I have a function that says add 2 to whatever is put in. So I put in 5 into this function, and what do we get? 5 plus 2 is equal to 7, and so our output is 7. Now let's say I put 100 into this function. The output will be 100 plus 2, which is equal to 102. Now I'm going to put in a variable x into this function. So the function now adds 2 to it, and what is my output? Well, you guessed it right. It's x plus 2. If I put in x squared into this function, the output is going to be x squared plus 2. Basically what I'm saying is that whatever you put in this function that has a rule of add 2 is going to add 2 to it, so that your output will always be 2 greater. Now let's look at another function. The rule of this function is whatever you put in gets multiplied by 2 and then you add 3. Suppose I put in 4 into this function. What will happen? 4 gets multiplied by 2 and then you add 3, which means your answer is going to be equal to 11. On the other hand, if I put in negative 5 into this function, what's going to happen is negative 5 is going to be multiplied by 2. I will get negative 10, and then I'm going to add 3. So my output is now going to be equal to negative 7. Are you beginning to get the hang of this now? Now I want you to think about what will happen if I put in x into this function. So this function multiplies x by 2 so that I get 2x, and then it adds 3 so that you have the output as 2x plus 3. Technically, this function can now be written as f of x is equal to 2x plus 3. And this is now the rule of this function, and you read it as f of x is equal to 2x plus 3. To fully define a function, we need a rule and a range of values of x, which is called the domain. The range of values in the output or the y values of the function is called the range. Now let us consider the function y is equal to x squared for all positive values of x only, so that x is greater than or equal to 0. So the rule of this function is y is equal to x squared, and the domain of this function d is equal to x such that x is always greater than or equal to 0. So when I plot this function, the function will look something like this. That's not a perfect drawing, but that's how it will look. Now if you look at the corresponding values of y, you will see that all values of y are only positive, which means that the range of the function can be written as r is equal to y such that y is always greater than or equal to 0. So now we have defined the domain and the range of the function. Now I'm just going to tell you something rather ridiculous, because how do you remember that the domain is x and the range is y? Have you looked at the supermarket shelves and seen a toilet cleaner called Domex? Now that's how I help my students remember. Dome X, domain X. Such a funny idea, isn't it? But I promise you will never forget that the domain stands for X. Now what are composite functions? Suppose we have two functions, f of x is equal to 2x plus 3, and the g function g of x is equal to x squared. Suppose we put an input of 2 into the f function. It's going to get multiplied by 2 and add 3, so that your output is now going to be 7. Now this 7 becomes the input for the next function g, which will become 7 squared is equal to 49. So the output of the composite function g of f of x, because we are putting the f function to the g function, is equal to 49 when x is equal to 2. This can also be written as g of f of 2 is equal to 49. Now suppose I put an x into the same function. My output is going to be 2x plus 3, which then becomes the input for the g function, which is going to square it. So now if you think of g of f of x, into the g function I am putting in the f function, which is 2x plus 3. And what does the g function do? Whatever I put in, it squares it. So my output will be 2x plus 3 the whole squared. Therefore, the definition of the composite function in this case would be g of f of x is equal to 2x plus 3 the whole squared. Did you get that? Now just to make sure you've understood what I mean by composite functions, I'm taking two more different functions, f and g again. F is equal to 2x plus 1 and g is equal to 3 minus 4x. Now I want to find out what is the value of g of f of x, which means I'm going to put an x into the f function so that I'm going to get out 2x plus 1. And this is now going into the g function, which will make it equal to 3 minus, instead of x, my input is now 2x plus 1. So that you get 3 minus 8x minus 4, which will give me negative 8x, negative 1. So g of f of x is now equal to negative 8x minus 1. Now I want you to look at what could be the value of f of g of x. So what are we going to put in? Into the f function, I'm going to put in g of x. And what is g of x? 3 minus 4x. So into the f function, instead of x, I'm going to put in 3 minus 4x. So into the f function, instead of x, I'm going to put in 3 minus 4x, and then I add 1, which is now equal to 6 minus 8x plus 1, which is equal to 7 minus 8x. Now what I want you to notice here is that when I put in the f function into the g function, I got negative 8x minus 1. But when I put in g function into the f function, I got 7 minus 8x. So this tells me that f of g of x is not the same as g of f of x. Now this is a very important concept for you to remember. A topic like functions cannot be taught in 10 minutes. There is so much you still need to know. Things like inverse functions and its applications. Unfortunately, I've run out of time. So till we meet again, bye and have a nice day.